You look at this and you think, this is the last question. This is meant to have some kind of, oh, I know they're beaming. It's not as bad as it looks. It does look a little weird, I'll admit, because you got your sine to the 5, and you're thinking you should have something to the 4. Like, you're thinking reverse chain rule, okay? But they give you a clue to actually tell you you're not going to necessarily need that, okay? So they give you this substitution. Let's see how far we can take it in order to solve this question, okay? So if they've done that, we're integrating, right? The very first thing you should do with the substitution is you should differentiate it, okay? Because we can't substitute it in just yet. Okay? So if I take du on dx, what's that equal to? It's just cos, isn't it? Okay. Now you can do this in two different ways. You can either say du is equal to cos x dx, and that's okay, right? The reason why that's okay to say is because I have a dx and a cos x in there. I have more than that as well, but I have at least that. Alternatively, you might prefer to make dx the subject, and I think you'll get du over cos x because you'd just be dividing through, okay? Now, you might prefer that because you can just substitute it straight in and see what happens, okay? I've differentiated. I can get rid of this. I've got this substitution, I can get rid of this. There's one more piece I need to get rid of. Actually, there's kind of two, but there's one that's obvious. What am I missing? What haven't I got rid of yet? It's a definite integral, right? Definite integral. So I've got these zeros and piles and two. So I've got angles because I've got trig functions, which makes sense. But if I'm going to move all of this stuff into u, right? These are x boundaries, so I've got to change them into u boundaries as well. So I'll just do that very quickly. Just to reiterate, you don't have to draw the table, but it's kind of useful sometimes. 0 to pi on 2 is going to correspond to, this is sine, right? So that'll be, sorry, that's a terrible 2. That's 0 to 1, I think. Sine of pi on 2 is 1. Okay. So let's rewrite this. Now, this is one of those tricky examples where what we try to do is get rid of all the x's and replace them all with u's, right? And you can do that in this question, but it's a little hard to see. So I'm going to be a bit naughty and do it in pieces. I'm going to do it halfway. Okay? So 0 to pi on 2 becomes 0 to 1. Sine of the 5x just becomes u to the 5, right? Okay, now this guy I have not resolved yet. Okay, I'll go with this way because I see that's what a lot of you have done. So I'm just going to follow that method, even though this would work fine. I don't have anything yet that'll get rid of my cos cubed. Okay, so I'm just going to write him down. This is the naughty bit. We try to avoid that. Don't like using x's together. But now I've got my dx here. Okay, so that's du over cos x. At least that's the substitution I've chosen. Okay. So remember, my goal is to get rid of all the x's. I'm changing this into a different kind of question, right? So the first thing I can do is, well, I can get rid of that cos x, and I get a 2 there, right? It doesn't look like it's much better because I still have all of this cosine in there. But I can do something with this. I can do something with cos squared because I need to get it in terms of sines, but you can do that, right? What identity will you use? You'll use the, it has a name, right? Use the Pythagorean identity. So we're used to saying sine squared plus cos squared equals 1, right? So therefore you can say off that cos squared is equal to 1 minus that. Okay, so I'm going to use that here. So 0 to 1, u to the 5. This is 1 minus sine squared x du. Okay, and now at last I can actually get rid of all of my x's. Okay, so I've got this as u, so I'm just going to go 0 to 1. That's 1 minus u squared. Okay, this is just a polynomial. I can do this. This is not bad. I might as well just expand it quickly. That's u to the 5, u to the 7. Yep, you can go from there. Let's just quickly get the value out, shall we? This is going to become u to the 6 on 6. This is going to become u to the 8 on 8. And I'm going from 0 to 1. So I've got a 6th minus an 8th minus 0, which I think is 1 over 24. I think. So what was tricky about this question was that all of this stuff, which usually gets rid of all of the pieces here, wasn't quite enough. You had these leftover bits, okay? But number one, they gave you this clue, so you're like, okay, at least I know I'm headed in the right direction. So it's not like I picked some bogus method. Unlike, earlier there was a question, question 2 part E, and if you didn't use T results, you could still get it, but you'd go round and round in circles. But they didn't tell you to use T results, right? Here, they did tell you what method to use, so you had to have a little bit of faith that it was going to work out in the end, okay? But it's not so bad. Remember, the goal is just get rid of all of one variable, convert them all into the other, and you